So good evening, welcome to Sakala Vidya YouTube channel. So now we have been discussing 10th class mathematics. Okay, that is also chapter trigonometry. So now we have completed up to 10 problems. Now we need to discuss set 3, today set 3 problems. Set 3 problems. Right. So all of you subscribe. Soni, Lakshmi, Srinivas, Bharat, welcome. Jaya, Harshavardhan, Vijaya. Okay. Fine. So first question. Yes. Show that sin A plus cos A whole square plus sin A minus cos A whole square equals to 2. So let us do this problem. Show that sin A plus cos A whole square plus sin A minus cos A whole square is equal to 2. Okay, Rajan, welcome. Vandana. Okay. So now the solution. Take left hand side. Sin A plus cos A whole square plus sin A minus cos A whole square. So we need to use two formulae. So one is A plus B whole square. A plus B whole square equals to A square plus 2AB plus B square. A minus B whole square equals to A square minus 2AB plus B square. So using these two formulae, this problem can be solved. Okay, Sivagangadhar, welcome. Okay, now the sin A plus cos A whole square is in the form of A plus B whole square. So we can write sin A whole square, A square plus 2AB 2 times sin A and cos A plus cos A whole square, and plus we have sin A minus cos A whole square we need to write. So that can be written sin A whole square plus this is minus 2 times sin A cos A plus cos A whole square we can write it. So let us simplify to get the answer. Yes. So now this equals to sin A whole square is sin square A plus 2 sin A cos A plus cos square A plus sin square A minus 2 sin A cos A plus cos square A. See, here we have plus 2 sin A cos A minus 2 sin A cos A gets cancelled. So we have, see, check, sin square A plus sin square A, 2 sin square A plus cos square A plus cos square A, 2 cos square A. We shall take out 2 common. So 2 common out, we have sin square A plus cos square A. Sin square A plus cos square A is 1. Am I correct? So 2 times 1 is 2. This is RHS. That's proved. Yes, yes, yes. Okay, now second question. If sin A plus cos A equals to A, in brackets A does not equal to 0, then express the value of sin A minus cos A in terms of A. Just think of about this question. Think about this question. So what is the answer? All of you like, subscribe and share. So this is very simple. First write down like this. Given sin A plus cos A equals to A. So we need to find out sin A minus cos A is equal to question mark. See, we know that sin A plus cos A whole square plus sin A minus cos A whole square equals to 2. Just we proved in the sin A plus cos A whole square plus sin A minus cos A whole square is equal to 2. Am I correct now? So let us substitute here. Let us substitute. So now the sin A plus cos A is equal to A. Substituting A square plus sin A minus cos A whole square equals to 2. Transpose A square that side. So sin A minus cos A whole square equals to 2 minus A square. But we need sin A minus cos A. Therefore sin A minus cos A equals to root over 2 minus A square. This is plus or minus. This is the answer. Okay. So third question. Show that so 1 plus sin theta upon 1 minus sin theta equals to sec theta plus tan theta whole square. Sec theta plus tan theta whole square. Okay, can you prove this question? Can you prove? Show that 1 plus sin theta by 1 minus sin theta equals to sec theta plus tan theta whole square. This problem can be done in two ways. By considering left hand side or by considering right hand side. So anyway you can solve it. Otherwise left hand side minus right hand side is equal to 0 also you can prove it. Okay, first let us solve now this question. So left hand side, so 1 plus sin theta upon 1 minus sin theta. So multiply both numerator and denominator with 1 plus sin theta. Suppose here 1 minus sine theta is there, you need to multiply with 1 plus sine theta. Suppose instead of 1 minus sine theta, 1 plus sine theta is there, you need to multiply both numerator and denominator with 1 minus sine theta. You remember like that. So now the next step follows like this. 1 plus sine theta upon 1 minus sine theta multiplied by 1 plus sine theta upon 1 plus sine theta. This is the important step. That means indirectly, so it has been multiplied with 1 itself only. 1 plus sine theta cancel 1 only. So you will be getting same thing. The identity will not change. So now 1 plus sine theta into 1 plus sine theta, you can write 1 plus sine theta whole square. Okay, 1 plus sine theta whole square. So this we can write it now. So a minus b into a plus b, a square minus b square. So we can write 1 square minus sine theta whole square. Right? Am I correct? Yeah. So 11th का मैथ्स पढ़ा ना के बाद में बोलेंगे. So this equals to 1 plus sine theta whole square. Don't expand it. Keep like that only. You get 1 minus sine square theta. So here don't change the numerator. We need to, this is called numerator. This is called denominator. So now we need to change the denominator. So we know that sine square. See, sine square theta plus cos square theta equals to 1. So sine square theta plus cos square theta equals to 1. So take sine square theta that side. So what do you get now here? Cos square theta equals to 1 minus sine square theta. So now instead of 1 minus sine square theta, we can replace cos square theta. So 1 plus sine theta whole square upon cos square theta we can write. So we have one important formula. See, a square upon b square is there. This we can write a upon b whole square you can write. So using this one, no, not rationalizing. This is not called rationalizing. That is a different way. Okay. So now this can be written as 1 plus sine theta upon cos theta whole square. Now separate the LCM. This can be written 1 upon cos theta plus sine theta by cos theta whole square. See, 1 upon cos theta is sec theta plus sine theta by cos theta is tan theta. So sec theta plus tan theta whole square. This is RHS. Hence, it is proved or it is showed. So Mukti classes. Right. So fourth one. Show that so 1 minus sine theta upon 1 plus sine theta equals to sec theta minus tan theta whole square. Can you solve this problem? Can you solve this problem? Fine, fine, Ali Baba. Fine, fine. Okay. Can you solve this problem? 1 minus sine theta by 1 plus sine theta equals to sec theta minus tan theta whole square. So instead of multiplying with 1 plus sine theta, this time you need to multiply with both numerator and denominator with same method. 1 minus sine theta. Okay, let us do it now. Solution. So left hand side 1 minus sin theta upon 1 plus sin theta. Multiply both numerator and denominator with 1 minus sin theta. So what will be the next step? You might have expected 1 minus sin theta upon 1 plus sin theta. So it is being multiplied with 1 minus sin theta upon 1 minus sin theta. Okay. So the next step you see, you get 1 minus sin theta whole square, because 1 minus sin theta into 1 minus sin theta. So 1 plus sin theta into 1 minus sin theta. A plus b into a minus b. A square minus b square. This is 1 minus sin theta whole square upon 1 square minus sin theta whole square. Now what do you get? 1 minus sin theta whole square. Don't simplify the numerator. Keep as it is. Upon 1 square is 1 minus sin square theta. So what is the value of 1 minus sin square theta? What need to be replaced instead of 1 minus sin square theta? Let us see. See, sin square theta plus cos square theta equals to 1. This is important identity. Take sin square theta that side. So cos square theta equals to, you get 1 minus sin square theta. Observe in the red color I mentioned. So this 1 minus sin theta is replaced by cos square theta. So now what do you get now? This is 1 minus sin theta whole square upon cos square theta. What can you write? What do you conclude? What do you conclude? So we may conclude that this can be written 1 minus sin theta upon cos theta whole square. So this equals to 1 upon cos theta minus sin theta upon cos theta whole square. So my dear children, once again remember 1 minus cos theta. What is 1 minus cos theta? Yes, sec theta. What is sin theta by cos theta? Tan theta. So whole square. This is RHS. Hence, it is proved. Hence, it is proved. Okay, fifth one. Show that one plus cos A upon 1 minus cos A equals to cosec A plus cot A whole square. Okay, can you prove this one? Can you prove this one? You try yourself. Sneha Misra, how are you after a long time? Sivagangadhar, Bharat, Lakshmi, Alibaba. Right, Bharat. How many of you can you solve this problem? Raise your hands. Oh, very good, very good. Okay, Lakshmi. So see the solution. Left hand side 1 plus cos A upon 1 minus cos A. Oh, very good, very good. multiply both numerator and denominator with, see here in the denominator we have 1 minus cos A. Opposite sign you need to take 1 plus cos A. So this can be rewritten as 1 plus cos A upon 1 minus cos A. So multiplied with 1 plus cos A upon 1 plus cos A. Right. How to good in algebra? So only the algebra, don't worry algebra, I will discuss. So now 1 plus cos A into 1 plus cos A, 1 plus cos A whole square. Am I correct? If you multiply these two, please check these two. 1 minus cos A into 1 plus cos A minus B into A plus B, A square minus B square. Okay, Nagalla Prasad Rao, I will discuss a special session on this one. Okay, don't worry. So this we can write 1 square minus cos A whole square. Okay, after completion of this problem, I will give the suggestion to you. Don't worry. So this we can write 1 plus cos A whole square. So 1 square 1 minus cos square A. So now very interesting formula we have. Sin square A plus cos square A. How much? Yes, you are correct, 1. So sin square A equals to how much? Yes, 1 minus cos square A. That means 1 minus cos square A need to be replaced by sin square A. Am I correct now? So instead of 1 minus cos square A, what shall you substitute? Sin square A. So that this can be written as 1 plus cos A whole square upon sin square A. So you might have expected the next step. Yes. See the next step. This can be written 1 plus cos A upon sin A whole square you can write. Separate the LCM now. Separate the LCM. So this we can write 1 upon sin A plus cos A upon sin A whole square you will get it. 1 upon sin A is cosecant A, cos A sin A is cot A, cosec A plus cot A whole square, which is desired value RHS. Hence, it is proved. It is proved. Okay, sixth question. Show that one minus cos A upon 1 plus cos A equals to cosecant A minus cot A whole square. Okay, can you solve this problem? Can you solve this problem? Are you able to do this problem in a systematical manner? Because this problem will be given in the examination for 4 marks in the final examination, board examination. It may be CBSE examination or ICSE or Andhra Pradesh, any board examination, it will be given for 4 marks. Even sometimes more than 4 marks also. left hand side, 1 minus cos A upon 1 plus cos A. So multiply both numerator and denominator with 1 minus cos A. So if you want to learn more mathematics, you need to explain others too also. You need to help. Teach others. Definitely will learn more. So now this equals to, now we can write 1 minus cos A plus 1 plus cos A multiplied by 1 minus cos A upon 1 minus cos A. So what do you get now? What do you get? So 1 minus cos A into 1 minus cos A. 1 minus cos A whole square. So 1 plus cos A multiplied by 1 minus cos A. What do you get now here? You get 1 square minus cos A whole square. For example, if you are in 10th class, you teach to the 9th class children. If you are in intermediate, you teach 10th class students. If you are in degree, you teach intermediate students. So because during this critical situation, you need to help others. So 1 minus cos A whole square upon, you can write 1 minus cos square A. Okay. So what is the formula we have? Sin square A plus cos square A equals to 1. Transpose cos square A this side. Yes. So sin square A equals to 1 minus cos square A. So instead of 1 minus cos square A, replace sin square A. So you get like this. So 1 minus cos A whole square upon sin square A. I think you might have expected the next step. So this equals to 1 minus cos A upon sin A whole square. So this can be written 1 upon sin A minus cos A upon sin A whole square. See, 1 upon sin A is cosecant A minus cos A sin A, cos A upon sin A is cot A. So whole square. This is RHS. Hence it is proved. Hence it is proved. That's it. Okay, you might be enjoying. Show that root over 1 plus sin A upon 1 minus sin A equals to sec A plus tan A, where A is acute angle. A is acute angle. Can you solve this problem? Can you solve this problem? This is also very important problem. Most expected question in the examination. Right. So now this time actually you need to rationalize the denominator. The rationalizing factor plays vital role to solve this problem. The rationalizing factor of root of 1 minus sin A is root of 1 plus sin A. Yes, now we need to rationalize. Somebody actually asked me the same doubt earlier. Take left hand side, that is root over 1 plus sin A upon 1 minus sin A. Multiply, this is called rationalizing only, both numerator and denominator. With root of 1 plus sin A. Not 1 plus sin A, root of 1 plus sin A. Just carefully observe. So now this can be written like this, root over 1 plus sin A upon 1 minus sin A being multiplied with root of 1 plus sin A upon root of 1 plus sin A. So this we can write root over like this, 1 plus sin A into 1 plus sin A, 1 plus sin A whole square. So this we can write 1 minus sin A into 1 plus sin A. This is the important step, turning step to solve the problem. So now we need to write like this, 1 plus sin A into 1 minus sin A. You check these two values. A plus B into A minus B, A square minus B square. So that we can write root over 1 plus sin A whole square upon 1 minus sin square A. Again we need to recall sin square A plus cos square A value, whose value is 1. Am I correct? Right? So cos square A equals to, you get 1 minus sin square A. That means here instead of this 1 minus sin square A, you can replace cos square A. So this can be written root over 1 plus sin A whole square. Don't expand it. Instead of this we can write cos square A. By taking square root, you get 1 plus sin A upon cos A. Separate the LCM. So 1 upon cos A plus sin A upon cos A. So what do you write? Sec A plus tan A. This is RHS. Hence it is proved. Hence it is proved. Eighth question. Show that root over 1 minus sin A upon 1 plus sin A. You might have expected, what is the value? Yes, you are correct. Sec A minus tan A. Okay. Can you solve this question? Can you solve this question? Where do you live, sir? Abhinav Sai, I live at Hyderabad. I live at Hyderabad. Where are you from, Abhinav Sai? So this time multiply both numerator and denominator with root over 1 minus sin A. Then you will get the answer. This is also one of the important problems, may come in the final examination. There is a chance of getting. Saranya, have you subscribed, all of you? Rajesh Gaud. Okay. Solution, left hand side, root over 1 plus sin A upon 1 minus sin A. You practice these questions, right? Multiply both numerator and denominator with root over 1 plus sin A. So you get the step like this. Root over 1 plus sin A upon 1 minus sin A. So being multiplied with root of 1 plus sin A upon root of 1 plus sin A. Oh, Vidya. Yes, sir, I have subscribed your channel. I know. Others. So this can be written as root over 1 plus sin A into 1 plus sin A, 1 plus sin A whole square. Sorry. I have written wrong. Wrong. Sorry. Wait. 1 minute. This is 1 minus sin A plus. That means 1 minus sin A. Right. This will be 1 minus sin A whole square. 1 plus sin A into 1 minus sin A. Okay, Shobharani, Vanam. So this we can write root over 1 minus sin A whole square upon what do you get? This will be 1 square minus sin A whole square. This is root of 1 minus sin A whole square upon 1 minus sin square A. Mokshit Reddy, after a long time, where had you been? Sin square A plus cos square A equals to 1. Take cos square A this side. So take sin square A this side. Cos square A equals to 1 minus sin square A. That means instead of 1 minus sin square A, cos square A, we shall write. So we get root of 1 minus sin A whole square upon cos square A. Square root of 1 minus sin A whole square is 1 minus sin A. Square root of cos square A is cos A. So what do you get? 1 minus sin A upon cos A. Separate the LCM. So 1 upon cos A minus sin A upon cos A. So 1 upon cos A is sec A minus sin A by cos A is tan A. This is RHS. Hence it is proved. Okay, now I give the homework problems to you. Homework. Complete this problem. First one. Show that root of 1 plus cos A upon 1 minus cos A equals to cosec A plus cot A. Second problem, show that root over 1 minus cos A by 1 plus cos A equal to cosec A minus cot A. Okay. So complete these problems. Shailaja, thank you Shailaja. Thank you. So tomorrow we shall continue the same time. 10th class timings will not be changed. That will be in between evening 7:30 or 7 o'clock like that. So please all of you subscribe and like and share to your friends. It will be very useful. You may get good marks in the examination. Right.